This is a very interesting limit question. Now, I would like to do with it by two methods. Now, before I'm doing this limit, let me recall something which is useful in our finding the limit in this question. Now, the first is that E could be this one, a limit, something goes to 0, and 1 plus something, and 1 over something here. That is E. Now here, star could be a single variable or a function. As long as that satisfying this is approaching to 0, while this one is the reciprocal of a star, which goes to infinity, then this limit is E. Or we can express E as the other one, the limit infinity goes to star goes to infinity, and 1 plus 1 over star and to the power of a star. Well, actually they're the same thing, right? This approaches to 0, this approaches to infinity, and a star could be a single variable, or star is it could be a function. Now that is one thing. The other thing I would like to recall is this: the derivative of y with respect to x, and y is a function of x and dx. That is, the definition is the limit h goes to 0 and f over x plus h minus f of x over h. Okay, let me change the pen. Okay, this is the definition of the derivative of f with respect to x. Now, that the derivative is actually the limit. And if we're looking for the derivative of f of x at a certain point A, well, or the derivative of f of a with respect to x, that is equal to the limit h goes to 0 and f of a plus h minus f of a over h. So this is the derivative of f with respect to x at the point A. You know, okay, these two limits, we are going to use it in our question. So let me write them here. So just to recall. Okay, now let's see this limit. Okay, now this limit is a sort of when this one goes to infinity, this approaches to 0, so whole thing approaches to 1. This approaches to infinity. So this is kind of a limit. This is kind of an indeterminate form we have in this question. So well, we let this be y, right? Method of 1, okay? And log y is equal to the limit n approaches the infinitive, and n multiplied by log tangent a quarter pi plus 1 over n. And this is equal to the limit n approaches the infinitive and log. Now we can use the formula for a tangent. That will equal to, right, 1 plus tangent 1 over n, 1 minus tangent. Okay, that is simply using the formula for tangent, and this was equal to the limit n approaches the infinitive and now this one we can write 1 minus tangent plus 2 tangent, right? So this becomes a log 1 plus 2 tangent to tangent 1 over x. Yeah, 1 minus tangent 1 over n. Okay, good. Now, look. I want this one is approach to this will approach to 0, right? So I try to use this to create my e. So here let me write another line, just make it clear that this is equal to infinitive e over n log bracket let me change the color. This is a 1 plus 2 tangent 1 over n, 1 minus 1 over n, and this is a reciprocal of 1 minus tangent 1 over x, 1 over n, 2 tangent 1 over n. Then all together to have a 2 tangent 1 over n, 1 minus tangent 1 over n. So that is equal to 1, right? Equal to this one. See, something good is that I have a, see, this is my star. This one goes to 0. This one is 1 over star. That's reciprocal of that. And then as n goes to infinitive, which means this is going to 0. Right? So I have a, this becomes the limit n goes to infinitive and log. Now I have an e. The red one is e, right? and to this one, to tangent 1 over n, 1 minus tangent 1 over n. That is this one. And then log e to this one, that will be equal to the limit n goes to infinity and multiply by this, right? This is 2 tangent 1 over n, 1 minus tangent 1 over n. And this could be written as the limit n goes to infinity 1 minus tangent 1 over n to this will be sine 1 over n over cosine 1 over n, right? And this n could be written as 1 over n in the denominator. So this one is n. That tangent is this, right? Now, as n goes to infinity, this goes to 0. This goes to 0. So this is a well-known limit. This one goes to 1. Sine something over something when something goes to 0 is 1. This goes to 1 because cosine 0 is 1. This one goes to 1. Therefore, the result is 2. Therefore, our limit, y is equal to e squared. Because the whole thing, log y is 2. Log y is 2, therefore y equals, this is our limit we are looking for. Okay, this is our first method. Now the second method, because it's second method, this is the limit n goes to infinity tangent. The pens are not good. Tangent quarter pi plus 1 over n to the power of n. Okay. I'll try to use a good pen. Okay, now this one is equal to the limit n approaches to infinity 1 plus tangent quarter pi plus 1 over n minus 1. Okay. Yeah. So then what? See, I have 1 here. See, I have 1. I try to, now this one goes to 0. This is 0. Tangent quarter pi is 1. 1 minus 1 is 0. Therefore, this is my star. This looks like my star, and I try to create a E somewhere. The E. Okay, now Let me write carefully. This is the limit. N goes to infinity. This is E plus tangent quarter pi plus 1 over n minus 1. Yeah. To the power of tangent quarter pi plus 1 over n minus 1. And n times tangent quarter pi plus 1 over n minus 1. Well, I hope you see this is not very clear. Okay, this is a 1. This over same thing is a 1, right? This is n. So altogether still n. This one still is equal to n. So therefore they are equal. But the red one, the red color is this, because this one goes to 0. This is 1 over star. So eventually this becomes the limit. No, the pens are not good. N goes to infinity. This is E. The red one is E. Right? And to the power of this is gone. To the power of n tangent quarter pi plus 1 over n minus 1. 1 is tangent to quarter pi. Correct? Yeah. Then this one is equal to the limit n goes to infinity. E. Wow. The pens are really bad. Now, this is equal to, this n is 1 over n. Okay. This is the arctangent. No, not arctangent. Tangent quarter pi plus 1 over n minus tangent quarter pi. That's exactly I wrote in the beginning that this is the derivative, the derivative of f of x at x equal to a. Okay. When n goes to infinity, that's 0. This goes to 0. This is like h, right? This is quarter pi is my a. Therefore, this one is looks like e to the derivative of a tangent x at x equal to pi, quarter pi, right? Yeah, that is exactly. Now, this I showed in the beginning. So this one is equal to e secant square quarter pi. See, secant quarter pi is 2. Therefore, this is okay. That is the limit. Okay, I hope you follow. I hope you like this question. I think it is a very nice question. You know, we are using two different methods, and it's a very interesting limit question. Thank you for your watching.